Hey everybody, I'm Ben from InterNACHI, and you're on NACHI TV, where we do free live interactive webinars for home inspectors. And we have a special guest, Kenny Hart, my buddy. He's gonna teach us a little bit about how to inspect air conditioning condensate drains. And we're gonna go 30, 40 minutes or so, and maybe some questions here and there. Kenny's always available for the technical, difficult questions, or maybe you can send him a picture of something you saw during an inspection. That's always good to share. And if you have a job scheduled, if the phone rings and you got to go, that's okay, because at NACHI TV, we record every webinar that we do, and you can watch it later. It'll be on our YouTube channel and in our newsletter and all that good stuff. So I think we're just about ready to go. One thing, just some logistics. You should be able to see me and hear me, but I can't see you or hear you. So if you wanted to ask a question now, during, or after the webinar, somewhere on your computer at the bottom right corner somewhere, there's like a chat window. You can just type in questions. And what would be really good and valuable to me and Kenny right now is if you can actually chat right now and tell me that you can actually see and hear us, because that's always a good thing, just to make sure. We almost had 200 inspectors register to attend today. So it's a really good, popular topic. I think it's gonna be hit on YouTube for a long time. And oh, good, Angela says hello, and Phil, Ajit, Bruce, and Neil. All right, so it sounds like everyone can hear and see us all. And so what I'd like to do is change the presenter from me to Kenny Hart. And a little pop-up window, Kenny, should go on your side.
All right, I got it.
All right.
Okay, well,
we see your desktop with the presentation slides.
Okay. All right here. And I can start that anytime, I guess.
Yeah, you probably want to go into like some kind of presenter mode or something.
Yeah, here we go. Anyway, let's get going here. I appreciate everybody. Got it?
Yep.
Okay, appreciate everybody attending today. I get a lot of questions all the time. I've done seminars now for like, I don't know, I guess I'm pushing 20 years. I also teach HVAC classes, plumbing classes, different things like that. I've written articles and so forth. So I get a lot of questions. I get them emailed all the time. And I've noticed a lot of them are concerning air conditioning condensate drains. So over the years, I've gathered up a few pictures and things like that, and I've put them in this little presentation here, which hopefully will answer a lot of your questions. There are a couple little video clips I've inserted in this, and maybe it'll make it a little easier to understand. If not, feel free to email me. I got a Facebook page. I got quite a few people on the Facebook page. You can follow the page. I post things on there all the time. You can, again, you could email me, theplumbingandhvacguy@gmail.com. You could also go to Kenny at kchartandcompany.com, and I'm happy to answer questions. Sometimes it'll take me a day or so to get back to you. I do get overwhelmed sometimes with things, but happy to try to help you guys as much as I can. Air conditioners, and really we should say heat pumps, because when they're in the air conditioning mode, they can produce, the numbers run a little different, but between 5 and 20 gallons of condensate water a day. Where I live, really high humidity. I'm in Virginia Beach, real high humidity, 90 degrees summers. You'll see the air conditioning condensate drains on the side of the house just pouring water, and you remove that water, it feels a lot better in the house, but there's a lot of water being removed. If we don't get rid of that water properly, we can end up causing all kinds of damage to the structure. People could get hurt by it and so forth. Here's a kind of a little image that you don't want to see if you've been in the business and you've inspected a house. Ceilings come down, we got mold growing. These are pretty common things in the HVAC business. We see these things from time to time. This is my 45th year in plumbing and HVAC. So I've seen a lot of stuff over the years. And I know when I see something installed improperly in the field, these are the things that can, come back and haunt you later on. All right, let's do some basics first. Condensate, drain, basics. Some of the things that kind of across the board. There's been a few changes recently in some of the codes, and I'm not getting into codes. I'm just going to talk more about the general things. All right, the primary coil should be trapped so the seal resists air pressure. Now, this could be on a system that's under positive pressure or under negative pressure, but we should trap it. It's generally required by most manufacturers on pressurized or systems, we blow through systems or draw through systems generally required. Draw through systems is extremely important. On a draw through system, you don't trap it properly, you usually end up with a flood. Trapping, the traps themselves, we refer to them in the business as running traps. They tend to not be real good. I mean, they kind of work sometimes depending on the static pressure in your duct system and so forth. But a lot of times when a system starts out, it can actually suck the water out of the trap. And until the unit shuts off, the water doesn't go back into the trap and reprime it. So in most cases, you're better off if you have like a P-trap. Now, the one in the middle is the one I would prefer, usually because it's a nice, clean, sweeping trap. Now, it has to be deep enough, and a lot of this stuff comes from the design of the duct system and so forth. And we can't really get into that as home inspectors. We don't, figure out static pressure and all that on a duct system. But the one in the middle works pretty good. The one at the bottom is very common. The one at the top, the trap at the top is a little shallow. It can kind of suck the water out of that thing, negating the value of the trap when it does that. But the other two work pretty good. Now, when I see the running trap, and I mentioned it a minute ago, I don't necessarily write it up if everything seems to be working properly, because I really don't know what the pressures, the static pressure and everything is in the duct system. So I don't know if it's working well or not. There's just no way for me just to look at it unless it's actually cranking right then on a hot summer day. I may not know exactly what's going on with it, but I do look for stains, indications that maybe the system has overflowed at some point. I look in the wintertime, especially when we kind of at a loss about some of the things we're going to inspect on the HVAC system. I look all around the unit. Do I see water stains? If I see water stains, I make sure I point that out. And I may even give them a note, because I am a licensed HVAC contractor. I give them a note, say, may have something to do with your trapping, have somebody come out and check it. But if I see P-traps, generally I'm not overly concerned. I figure they can probably operate well. One of the things, we don't drain to a public way. They don't want water running out onto a sidewalk, basically, or an area where somebody could step in it. Sometimes these things end up forming slime and stuff like that. You don't want anybody to get hurt. You don't want to track through water, things like that. The pipe, pretty much across the board, manufacturers and the code says 3/4 of an inch minimum, about 1/8 of an inch slope, supported well. You got to do that, otherwise the little dips that you get in the trap the dips that you get in the pipe end up being a trap. That's what I'm trying to say. So that stuff can slime up pretty bad. So good support, 1/8 inch slope, or maybe a little better if you can, and just 3/4 inch, you'll probably do pretty good. May drain to indirect waste. A good example of an indirect waste would be a wash machine drain. We actually do drain to wash machine drains in some areas. Other areas, they may say, no, you can't do that because we don't want to treat your condensate water, through our sewer system. So you kind of have to figure out what the local authority is allowing, but an indirect waste is pretty common. Here in Virginia Beach, we almost always drain out on the ground. Pipe pops out the back of the house somewhere, turns down with an elbow. Otherwise, it can run back into the wall. Turn down with an elbow, and we drain down onto the ground. Here's a good thing, good image here. We show it going into a laundry tray. We try to get a little air gap there. We don't want the lines shoved right down in the laundry tray. They show an image here of it going into the overflow on a bathtub, in the back of the bathtub. I've never seen it. I can understand how you can do it. I could also think in the middle of the night, it's going to drive you crazy hearing that water trickling in the bathroom, down the hallway. But I can understand how it could be done that way. And then the condensate line could go into the trap, above the trap, and the tailpiece above let's say a basin. I got an image here that's going to come up in a second showing it doing that. They're also showing it here, a no, don't put it through a hole in the floor. You have no idea where it's going. It could cause all kinds of structural problems, could block it up. Do not go popping it into a plumbing stack. You get a situation there where you usually end up with sewer gas in the house. And then the other image, they're showing it coming out on the wall. And in this particular case, if you turn down the wall a little ways, get down near the ground, turn it down with an elbow and then kick it away from the building, splash pan or whatever, you'll probably be fine in most cases. Here's the drain I was just mentioning. This kind of looks like a wash machine connection under a lavatory, but that's what they're doing here. They're using this branch fitting. They don't have to worry about sewer gas because, the lavatory gets used several times a day, so the water keeps the trap primed. And so that can drain in there. The biggest negative on this might be you might live in a locality where they say, hey, we don't want to treat condensate water in our sewer system. They don't want to mix that water. In other areas, they might not care. Here in Virginia Beach, we have a few neighborhoods where they allowed this years ago, so they still allow it. But in other areas, they just flat out say, no, you can't do it that way. Throw it out on the ground or go to an indirect waste where it's not necessarily going to go into the sewer system. Maybe, some way to get it into a storm drain or something like that through an open line. This is pretty popular in some areas. We run into a wash machine drain, but the way you do that, and of course you're going to end up treating this water, the best way to do that would be to put a fitting in the standpipe, run up to the wall. You can put a box in the wall, and then you actually bring the condensate drain from overhead. We have a lot of attic installed units, so we see this pretty regularly here. And what you do is you bring the condensate drain through the top of the box. When it's all framed in, it looks nice and neat, and the water again can drain. It's going to go down the drain, so the city's going to have to treat that water, or your sanitation department is going to have to treat that water. So if you have a situation where they're allowing you to put it in the line, a lot of times plumbers work with the HVAC guys and we install a fitting like this. That way the trap's going to stay primed. You're not going to get sewer gas. It's able to drain right into the system. And again, the negative for me is that stuff like that drives me crazy at night. I can hear stuff like that running and it just drives me nuts. But again, it's allowed in some places. It's a way to go into an indirect waste line like that. Here's just an image that I pulled up showing, it's a Carson Dunlap image, just showing you one going into the a vent pipe in the attic. The trap initially is going to have water in it. The winter time, though, it's going to dry out. When it dries out, you're going to be drawing in some sewer gases into the system. So when it's operating in the summer, you might think, hey, that's working pretty cool. No problem. I don't smell anything. I'm getting rid of the water because the vent eventually is going to get into the sewer, et cetera. But that trap's not going to stay primed very long. So unless you can get into the plumbing system in a way where you can keep a trap primed, you're probably going to have problems. So pretty much, the localities that I know, pretty much all the localities I see out there, they say, hey, look, don't do this in the stack. And I actually have an image of one right here. If you look at this, there's an air handler sitting on a platform over a pan. The condensate will actually drain to the line here into the stack, and it's going to go down the stack, so it's going to end up in the sewer. It's going to flow into the city sewer, but the sewer gases flow through this pipe out through the vent. So if this unit's running, especially if it's a draw through system, when that trap goes dry in the wintertime, that trap it's got water in it in the summertime, but in the wintertime when that trap dries out, boom, sewer gas into the house. You're going to just be sucking it right in. And then you have to deal with the concerns that you could have with sewer gas, the dangers of sewer gas, not to mention the odors. All right, downflow units. This is kind of a recent thing I've noticed in some of the code areas. Downflow units require a blockage detector in the primary pan, it says. What they're talking about here is, in most cases, you're talking about a furnace. So you got a furnace sitting on top of an evaporator coil or an indoor coil. They're saying, you got to put a primary drain on it, but they're saying get a blockage detector of some type in the primary pan. I wish they would say the primary tray. There is a condensate tray inside of the unit, and I think it confuses some people when they see pan. They're thinking an emergency pan or something like that. But essentially what we're saying is this primary drain on a downflow unit could block. And in some cases, they're sitting kind of close to the floor, and it could run over. You may not even know it. It may be running under a house in the case of a crawl space, and it could be running under the house for years before you ever realize anything's going on. So what what we are recommending here, and what in some areas the code saying is you need to put some kind of an indicator there so that if that drain does get blocked, in my case, I would wire it so it would shut the unit off. So, you know, a guy would come out, he said the unit's, you know, I got a 24-volt circuit that's open, I got to figure it out. He figures it out, oh, it's the detector, or in my case, the float switch. He said the float switch has got it shut off, and he realizes the drain's plugged up, and stops the drain, puts everything back into order. In the meantime, you're not running water in the crawl space for a long period of time. So this is required in some areas. It's certainly a good idea to do in others. This is a downflow unit. The unit is essentially pulling air here. And if you look at it, it's sitting, the equipment is sitting on top of, the furnace is sitting on top of the evaporator coil. So it's blowing down. It's a downflow unit. On this particular one, it looks like they got a condensate pump here. But what they were saying is, let's say that this was a crawl space, put a primary drain on it, and then maybe use a float switch on your secondary drain like they have here. And, the drain blocks up. It's prone to do that from time to time. The float switch will cut it off. It'll just shut it down. When I wire these things, I always wire them so that they'll shut off the outdoor unit. I don't really want it to shut off the whole system. As a service tech, I learned a long time ago, if I can give them fans operation, even inside the house, even though it's not cool air, if I can give them some air in the house, they tend to let me wait till tomorrow morning to come out there and make the repair. So that way I don't have to get up in the middle of the night and go deal with something like this. So all I ever do is use the float switch to shut off the outdoor unit, to shut off the condensing unit, or a heat pump, I'd be shutting off the outdoor unit. All right, condensate pump to a gravity drain. A lot of times you'll see a line going way across the house in this little teeny rubber hose, whatever they've got connected to it, and it's going, 30, 40 feet or something like that. It's kind of rough on these pumps. Some of the pumps won't handle it. Some of the pumps, bigger pumps will. But what they're emphasizing here, the best way to deal with this is run the pump and the drain, or the discharge line on the pump, as far as you have to get to something that you can then let it drain by gravity. So a lot of times in a basement, the best way to hook it up is let it pump up in the air, get into a pipe that you might secure that will actually flow by gravity. And you can do it in such a way that, it doesn't put such a load on the pump by doing that. A lot of times I've seen guys, they'll run the small hose up above the equipment. Then when they can get out on a gravity drain, they just fasten a gravity drain to the wall of the structure or something like that. They let that hose go right into the open pipe and let it run out by gravity, instead of trying to pipe it all the way out and put a lot of that long hose, putting the back pressure on the system.
Hey, Kenny.
Yeah.
Hey, we've got Phil here. He just wanted to comment. It's a pretty cool comment regarding discharging into public areas. It's common in Las Vegas, he says, to terminate the secondary line at the garage ceiling, right above the garage entry door. So it's a quote unquote conspicuous location, so that people can actually see a problem.
Yeah, that's actually required to where you do that. I've got a slide coming up on that in a minute, or that it'll remind me. But that's a good idea. What you want to do is be able to realize there's a problem. Like I had a situation one time, not related to condensate pumps, but I had a water heater discharging in a crawl space. This crawl space was tall enough you could walk under, but the water heater about every 4 hours would blow a hit of steam in the crawl space. They ended up with $30,000 worth of structural damage in the crawl space because they couldn't see anything going on. That's why you terminate water heaters, the TPR valve on water heaters, where you can see them, where you kind of walk by it occasionally, so you'll know that that there's an issue. So same thing with condensate. If you're dripping condensate somewhere and you're not able to see it, it might be causing damage to the house. In our area here, we put them in the soffits a lot. The one line to the overflow, the secondary drain, we'll put it in the soffit and let it drip down over the kitchen sink window. It's a very common thing for people to stand at the window, do dishes, or just walk up there and fill a cup, and you're looking out the window, and then one day you realize, what the heck, there's water dripping from above, and then you start realizing something's going on. You go outside and look. So that is kind of a common thing, and I can understand how they might do that out in Vegas, so you'd be able to see it.
Matthew asks, do you think the condensate fittings should be glued or unglued so you can get in there and clean them out, or?
Well, I mean, maybe the elbow on the end, you might want to. I don't see that that's a big deal as long as it's good, snug, tight. Some of the plugs I'm going to show you in a little bit, right at the traps, you can use a threaded type fitting, but a lot of these caps that we put on a vent pipe, I would never glue them on the vent pipe. I just press it on there, as long as water is not going to get up that high. Now the trap itself and the lines going from like the trap to the outside flowing through the attic, I glue them. If you ever worked in the HVAC business, you've probably go into the supply houses and you see all the cool tools and stuff that they have. We got all kinds of stuff for this now. We got devices that we can stick into the pipe and we can suck the trap clean, and we got devices that we can put in there and we blow the line out. We blow the trap clean. So there's all kinds of gadgets for that. And my concern would be if it, was going across an attic or something, if everything wasn't glued where it should be, and you might blow something apart and then end up having some problems there. But caps and the elbow on the end, it's just not that big a deal. Here's a condensate pump. It's kind of always been a pet peeve of mine. I'll see people put a condensate pump on a system and they won't use the interlock switch that's built into this thing. A lot of them can be made to close a circuit. Some of them are made to open a circuit. If you're going to close a circuit, what you do is the small wires that you'll see hanging out of this thing, we'll set it up so in the case the condensate pump fails, it'll set off an alarm. But if it is done another way, we can also set it up so it will open a circuit and we just cut off the outdoor unit, or we can cut off, using line voltage circuitry, we can cut off the equipment, and that way the pump failed, we shut it off, the equipment off, people get hot, they call somebody, he comes out and realizes, yeah, the drain stopped up and the float switch shut it down. And so I used to always tell guys when I would do these classes, make sure if you see these wires hanging out of the unit, you report it, that they didn't use this switch. It comes with the equipment. It's like they give it to you and people wouldn't use them. The HVAC guys wouldn't use them. So I say, absolutely, use them. Well, now it's actually noted in some of the codes where if the unit's in the attic, you have to have a condensate pump up there for some reason, or if it's in a like a crawl space or something, you're supposed to make sure that it shuts the equipment down. As an HVAC guy, I would use that switch everywhere. I mean, I just don't see any point of letting the thing run water anywhere with all the mold issues and things like that people are freaked out about today. Just use it. It's there. It's part of the equipment. I'll show you how you actually stick them in here in just a few seconds. Oh, here you go. We've got a condensate pump going to be installed on this system, and in it's going to catch the condensate water. It's going to be ready to rock and roll. And you just come in and you cut the line, the yellow line here. I cut it. Boom, boom, wire nut. Now that switch, if that pump fails, that switch will shut off that low voltage line going to that outdoor unit. It'll actually shut it off. It'll break the circuit, and now the thing will shut down. People will realize it's hot in the house, and they'll get to checking around. They'll find out that it's the drain is blocked. So anyway, protect from overflow with. This is kind of right from the code book. Secondary drain higher than the primary drain. What do they mean? You got a secondary drain on the equipment, use it. Use it. There's different ways you can use it. Use it. Use it so you can either drain the equipment with it, or you can use it to shut the equipment off. For instance, here's a unit. See the secondary drain, it's in red. Primary drain usually has a green plug when we buy them. So you got your primary drain hooked up. The secondary drain is there. A great way to keep the system from flooding is to use the secondary drain, pipe it out, just like you would pipe out the primary, or you could put a float switch in it. You could put a float switch in there and the water gets up a little higher, the float switch shuts it down. So that's a great way to do that. This piece of equipment here, if you pay attention to it, you'll notice that they actually connected the drain into the wrong openings. This unit could be used vertically or horizontally. And so what's happened is somebody got in there, put it into the wrong opening. So that's wrong. It's supposed to be in the green line at the bottom. And essentially the way this works, if you look at it, you're like, well, don't look like to me one's higher than the other. And it may not be, but there's actually a slope on that pan. So on the inside, when you look in there, that is a little bit higher. It's like part of the plug is blocked on the higher one. So You know, think of it as that when you actually screw that red knockout piece out of there, think of it as you look inside and you see half of the drain, the bottom part of that drain is actually blocked. So then the water gets up high enough, and it can flow out of there. But use the secondary drain in an emergency type situation. Or if you're going to use a pan like they have here, you know, if you want to leave it plugged and put their, you know, your emergency draining and maybe a float switch or whatever in the pan, that's fine too. But don't take the plug out. I see people all the time, they just take the plug out of the one up high, and it's going to suck in heat from an attic. And when the unit shuts off, sometimes if the pan's flooded, it's going to dump water out of it. So if you're not going to use the secondary plug, don't take it out. Here's a great example of using the drain on the right. He's got his primary drain hooked up, got a little trap. This guy even insulated it, so he didn't have to worry about it sweating. He's got the clean out fitting plugged between the trap and the unit, so there should be no air blowing out of this thing. And he took the secondary drain and put a float switch in it. This is ideal to me. When I do an upflow furnace, this is what I like to see. This is really a good way to go on a downflow furnace. Again, on this thing here, when you put a float switch in, you're just breaking the lines that are going to that outdoor unit. You're breaking one of the lines, putting the switch in. When the switch senses water, it opens up the circuit, shuts the unit off. That's the way that thing works great. Emergency pan with a drain. Okay, you can use an emergency pan under the unit and you can put a drain pipe on it. That's a great way to do it in an attic. Or you can put an interlock switch, a float switch in there if you don't have a drain. HVAC guys, they do that, but service guys would never want to do that, because service guys know if the pan fills with water and you got a float switch in there and it shuts it off, you're going to be up there mopping out the water and cleaning out the sludge and stuff like that. But an installer might do it that way. If the float switch cuts the unit off and it doesn't overflow that emergency pan, that's fine. I mean, you know, that's fine. That's going to work. But like I said, a true HVAC mechanic probably wouldn't do it that way if he didn't have to, because he's going to be the guy up there in the attic trying to mop out or vacuum out that pan if there's no drain on it. But if you have to, you have to, because sometimes I know on a retrofit, it's hard for us to get a pipe out of there if it needs an additional pipe. Here's a good pan. These pans are great. They actually have the little riser in it that you can put the equipment on, but you could use the drain line. You could run that drain line out. Maybe you couldn't get it in there. You could use the upper float switch there. You could put that in the opening there, or you could use the float switch to the bottom on the right. That actually fits over the lip of the pan, sits inside the pan, and it'll sense the water as the water rises up. And in that case, if you were going to use that, you would probably have it plugged off. But if you had a drain on it and a float switch, it's redundancy, but it's fine. It's great. I mean, it just gives you more things. I looked at a unit recently, and the guy had like 5 ways to keep this thing from flooding. I mean, you know, but you know, when you see the guy, you understand, because he wears suspenders and a belt. So I mean, that's the way that guy works. You know what I mean? But anyway, here's a unit. Now you see the trap, and then you got the secondary drain. It's plugged. You can see the little red plug in there. And when you're looking at the pan, that little white deal going behind it, that's part of the framing. That isn't a drain. But if you look on the right side of this equipment here, he actually has a wire going into the pan. And he's got a little float switch in the pan. So if this unit would overflow, it would flow into the pan, and then the float switch would shut it down. And you know, it'd be hard to miss if you're in that attic. If that pan was flooded, you'd walk up there and realize almost immediately what the problem is, suck the water out of it, clean the drain out, and let her get going again. Either one of these type of float switches would work fine in that situation. All right, secondary drain, readily observable. Somebody mentioned that earlier. We just need to know when there's a problem. We got to know when there's a problem. If you don't know, you don't fix things, and then you end up with more problems. You know, as I said about that water heater, it was like one of the last things I did on this particular house. I went into the crawl space, and the TPR valve blew off while I was in the crawl space, filled the crawl space up with steam, and that I realized exactly why the crawl space was so damp, even though in that particular area it normally wouldn't be that way. And again, moisture had damaged about $30,000 worth of structural work. And I remember that particular day, I said, this deal's done. I mean, I knew this guy's not going to buy this house with all this work. It's got to be done. But somebody would have noticed that line if it had been run outside or had been dumping somewhere where you just every now and then walk by it. you know, or you set it up like you say in Vegas from the garage. Here in Virginia Beach, you know, we put them in the soffit so it drips down by the kitchen window. Now, real quickly, blow through, draw through. There is a difference. Blow through units, when they run, it's like a furnace with a coil on it. You're putting your evaporator coil on the furnace. That evaporator or the indoor coil is under positive pressure. Okay, it's under positive pressure. The line is going to have air pressure coming out of it when that unit's running. So pressure's blowing up on the unit, and if you were to put your hand in front of the plug with the plug out, you would have air pressure coming out of there. It's under positive pressure. Most manufacturers say trap it, but I will just tell you, if you don't trap it, it'll drain because there's pressure on the system. It'll blow the water out of there when that's running. But if you trap it, it's like sealing up the ductwork. Why would you have a 3/4 inch hole in your ductwork letting the air come out when a little trap will take care of that? So that'll generally be the main thing to do that for, is to save the energy, to save the air pressure, and so forth. On a draw through, it's a little different. Quickly, here's a downflow. That coil is now under pressure. It would have air coming out. That's a blow through unit. That's how we hook up most furnaces. Horizontal, that coil is going to be under pressure. Air is blowing across it. Coil's under pressure. It would blow air out that opening. This unit here, there's your blower. This is very common for heat pumps. There's your evaporator coil. Over here, we got our heat strips. What's happening as this unit is running, it's a draw through unit. Air is being pulled across the coil. Air is being constantly pulled across that coil. That coil is in negative pressure. If there is no trap, if the vent pipe between the trap and the unit is open, or a drain pipe, clean out pipe is open, it will actually suck air inward. If it sucks air in, it may not be able to drain. If you do see one of these units in an attic and it's just kind of a different orientation here where they're blowing air pressure over, even though it may be set up, it kind of looks at, you kind of look at the unit and think, is this a blow through or a draw through? Just remember, the blower has to blow the pressure over the coil. The blower is upstream of the coil, and then it's a blow through unit. If it's sucking over the coil, it's a draw through unit. If you look at this unit here we have right in the classroom, there's my funnel. What we do is we pour water in this, we flood the pan, and if you look at the way this unit is set up, there's your primary drain. Here's your secondary. I see this installation all the time. People will put a pipe and maybe an elbow and turn it up on the secondary, and on the primary they'll put the trap in there, but then they'll put a clean out pipe or a vent pipe in the opening and they'll leave it open. And what happens is when the unit's running, that coil's under negative pressure. Air pulling in across the coil's under negative pressure, and I end up with air being pulled in here. You think, well, is that going to stop it from draining? It almost always does. I mean, there could be a duct system in such a way that it may not, but it is so rare that you've got to trap it, and you've got to make sure that trap is being used properly. Look at this video right here. See the arrows coming out of the drains. There's a primary and secondary drain. The guy on the left, I got the T opened at the top. The T being open on the top there is actually allowing air to be sucked in there. There's a trap under it, but the air gets sucked in. And on the right, they put this elbow in there. Maybe they turned it up, maybe they turn it down, whatever. Air's being sucked in there. Watch this as I actually turn it on. You can see the water being sucked backwards. All right, let's see if I can get this to roll for me. It's pulling backwards. As this unit is making condensate, it's not allowing it to release itself. Now, on an average day, it might not run over. It might not produce enough condensate. When the unit shuts off, it releases the negative pressure. The pan drains itself. But on a really hot, scorching day with real high humidity, it would probably run over. And then, it could cause a flood. And the installation is the problem. If you take this guy here, let's see, by the way, the way you fix that, real quickly, let me show you a real quick fix. Oop, I lost my picture. Where am I at? Ben, oh, here it is. Sorry about that. I pushed on the wrong button. Okay, on this one, you could plug it. You could actually put a plug in there. If you want to have a pipe in it, with the trap, you could, with a trap, you put a pipe in it with a cap on it, you could do that, but it can be removable. There's no need for it to be, permanently done there. Pull the little cap off the pipe and use it to clean out the drain, but don't leave it open. You don't want where that red arrow is to have a pipe standing up and it be open at the top. On the guy on the secondary drain over here, it's just turned up. I don't know what it is. It's got it in people's heads that thing needs to be open, but it does not need to be open. So to fix that, you can plug it, install a float switch on it, which is a great idea. It gives you a second way to shut this puppy off, or trap it. You could trap it and install it like you would do another drain, run the drain all the way outside, and it would work fine. But don't tie them together unless that line is going to be trapped. If you're not going to trap that line, it's going to do the same thing. It's going to allow air to be sucked back into the unit. It's going to, keep it from draining and do the same thing as if it was the primary drain. All right, here we go. Got 2 units, same thing. Actually, it is the same piece of equipment. Notice what I've done. I got a standpipe in one side or a clean out there. I put a little cap on the top of it. The guy on the right, I stuck a plug in it. They're not glued. Neither are glued. It's easy to pull out. The water pressure is not going to be an issue with that. And watch this guy when I actually have it running and it's draining. All right, notice the water's dripping out of that guy there. Now watch when I pull the plug, when I pull the cap. It stops. Now the unit's making condensate, it's filling up the pan. I put it back in and plug it off, it starts draining again. And that's where they fail. People will leave that line open there. If you want to have a T and an open line on the other side of the trap, that's fine, but not that side. It makes the trap useless. Look at the water being sucked back in there. And that's probably one of the biggest things I see out here in the field as an HVAC guy. I get called in on this stuff from time to time. Generally, I spend most of my time today teaching, but if I do get called in on expert witnessing or something like that, I just walk right up to the unit. 9 times out of 10, I can see it before ever really get to it. I can actually see what's going on because it's such a common thing that I see done wrong. Here's a guy in the attic, big pipe turned up on the secondary drain. All they're doing when this unit is running is sucking hot, humid air out of the attic. In case of Virginia Beach, that air is probably 140 degrees, 135, 40 degrees in the attic. It's got high humidity. You're putting it in the equipment and adding to the load that the unit's having to work on. It's not doing the job. Now, as far as the line on the right, the primary, I don't know if there's a trap down there. It doesn't look like it. And if there's no trap, it's doing the same thing. It's holding the water in until the unit cuts off, and then the water can flow through the pipe. But you can tell there's rust in that pan. So every now and then it fills the condensate tray completely up, it runs over, and it drips into the emergency pan. In an ideal situation, you would never have any water in the emergency pan unless it was an emergency. Something really fouled up on the system. I have people sometimes, they focus in on the draining part of it. Remember, sometimes the tray under the coil actually rust out. So water's dripping out of the unit, not because the drain's blocked up. It rusts out because the tray inside is no longer capable of holding the water. So that would be the reason for a tray to actually, to leak and then it get into the emergency pan. But, there's really no reason for you to install it in a way that you cause that problem. Missing plug, emergency pan's too short. These are real common. See it all the time. Connecting the primary and the secondary or an emergency drain together. Almost every instruction I've ever read always says run, if you're going to run 2 lines, run them separate. Don't tie them together, because from that point on, you only have 1 line now. And so if it blocks up, from that point on, that secondary drain is not going to do you a whole lot of good. Float switches on the wrong side of the trap. The traps are usually where most of the blockages occur. If that blockage would occur there, the water would back up into the coil box, into the tray, and it would run over. Now, if you had the float switch on the other side, on the other T, what would happen is the line would block up, and that you would see that slime all build up in there. It would push up on the float switch and it would shut it off. So this float switch will work if the line gets blocked from the float switch out, but it will not work. The float switch is not going to work when it's in the trap, and the trap is usually where the blockages end up. So, and I think I'm about ready to wrap up here, but if you look at this unit, did a pretty good job. They got the T's, got a little, you know, riser pipe in there with probably a press on cap. They got a float switch inside the pan, but they put an elbow turned down into the pan so that if this unit actually fills up with water, something happens, the trap gets blocked or whatever, it fills up with water, it runs into that pan. And you just don't need that. You don't really need to have that way. But in the meantime, as it's running, it's sucking heated air from that space. And if that happens to be a hot attic, you're sucking that heated air on a draw through unit. It's just sucking that air in, and it's adding to that load the whole time it's operating. So right there. Folks, that's my contact information. I got a website. We just licensed home inspectors here in Virginia, July 2017. I got a school here along with Mike Casey and I. We operate some stuff here together. Love to, you know, see you. We do a lot of CE stuff. Go to the Facebook page, like the Facebook page, follow me, and you know, click on message me, send me stuff when you got it. If you send me a picture, I will steal it. Promise you. It'll be in a show somewhere if it's really good, you know. But anyway, any questions pop up there, Ben? Otherwise, people feel free to email me and question, and I'll send you answers as I can. I'd love your pictures. Love your pictures. So,
Kenny, I really appreciate it. I know you're a busy fella, and you've got an amazing business and an amazing school. Everybody east of the Mississippi should be just driving right now to your school.
Well, and I would love that. I'd love that. We had a class last week, and you know, licensing people, and we had a good number of people here. You know, new people. So there are people joining the industry. You're getting in our business.
And I think if there's any weakness, in my experience with home inspectors out in the field, it's HVAC and plumbing. Electrical, you know, there's a lot of things, and people are freaking out about it, but it's kind of straightforward. There's a lot of things going on with HVAC and plumbing, and you know, the more the merrier. The more knowledge you got, the better you are. So, Kenny, thank you so much again.
Thank you. I appreciate it very much.
Thanks for being one of our great inspectors and taking care of our InterNACHI home inspectors and being at the conventions and all the events. And thanks for doing everything you've been doing for the industry. All right. I really appreciate it.
I'm glad to be here. Thanks, guys.
All right, brother. See ya. Bye, everybody.